Hey, it's Doc Williams, and in this video, we're going to determine limiting reactants using stoichiometry. Before we get into this problem, let's first understand what limiting reagents are. So let's look at this recipe for a cake. In order to make this 1 pound cake, you must have 2 sticks of butter, 3 eggs, 2 cups of flour, and 1 cup of milk. And if you change any of the ingredients over here or the reactants, then it would change how much of the product you would be able to make. So let's say I have only 1 cup of flour instead of two. Because the recipe calls for 2 cups of flour, this 1 cup that I actually have will limit the amount of product, which is the cake that I'm able to produce. So the flour will be the limiting reactant, while the others will be in excess. And the reason the others will be in excess, since I don't have 2 cups of flour here, there would be actually less of each of the other ingredients that would be needed to make the cake. So we can look at this recipe the same as we would look at a chemical equation, where we would need 1 mole of propane for every 5 moles of oxygen in order to produce 3 moles of carbon dioxide and 4 moles of water. Just like the butter, eggs, flour, and milk will produce the cake. And in each problem, we're going to use the amounts that we actually have to determine which of the reactants is going to limit our ability to produce the product and how much of that product are we going to produce. Now that we have a better understanding of what limiting reagents are, we're going to use stoichiometry to determine which of these two ingredients or reactants are limiting reagents in this problem. And you will hear me say reactant and reagent interchangeably. And depending on what your teacher prefers, they may use reactant, they may use reagent. Just know that they mean the same thing. Starting with our propane, we have 14.8 grams of C3H8, and we always want to start by converting the grams of propane into moles. And in order to do that, we're going to use the periodic table and calculate the molar mass. So using this space at the top, I have 3 carbons at 12.011 grams as shown on the periodic table, and 3 times 12.011 gives a mass of 36.033 grams per mole of carbon in propane. Now for my hydrogen. I have 8 hydrogens at 1.008, which is the mass shown on the periodic table, and that is a mass of 8.064 grams per mole. And if I were to add these two together, my total molar mass for propane is going to be 44.097 grams per mole. Now, in order to cancel out grams to convert to moles, I want to put grams at the bottom, and the number always attaches to the grams. So that's going to be 44.097 grams for every 1 mole of propane. And this is going to allow me to cancel out grams and leave propane or moles of propane. Now that I have moles of propane, I want to convert propane to moles of carbon dioxide. In order to do that, we're going to use mole ratio. To set this up, we're going to have the moles of what we want to get rid of at the bottom, which is propane, and the moles of what we want to convert to at the top, which is carbon dioxide. The numbers are going to come from the chemical equation. So we have a 3 for the coefficient of carbon dioxide, which will come here on the row of carbon dioxide. And when we don't see anything here, we know that is understood to be 1, so it'll be a 1 there. This will allow us to cancel out moles of propane, leaving moles of carbon dioxide. Now that we have moles of carbon dioxide, we want to convert that back to grams of carbon dioxide. And in order to convert moles to grams, we're going to go back to our molar mass. I am going to clear up some space here. We have 1 carbon at 12.011, which gives 12.011, and we have 2 oxygens at 15.999, which gives a mass of 31.998. So when we add these together, our total mass for carbon dioxide is 44 0.009 grams per mole. Since we want to cancel out moles, we're going to have 1 mole at the bottom, and we want to keep grams, so we will put 44.009 grams of carbon dioxide at the top. This will allow us to cancel out our moles of carbon dioxide, leaving grams of carbon dioxide. And now we just do our math by multiplying everything across the top, getting that answer, and then dividing that by what we have at the bottom, which is going to be 44.3 grams of carbon dioxide produced if we had 14.8 grams of propane and enough oxygen for this to go to completion. Next, we're going to do the same thing for oxygen. We have 3.44 grams of oxygen, and we want to convert oxygen into moles. Go into the periodic table to calculate the molar mass. Now we have 2 atoms of oxygen, which means we're going to go to the periodic table, get the mass for 1 oxygen, which is 15.999, and multiply that by 2 in order to get the mass of this diatom. So that would give us a mass of 31.998 grams per 1 mole of O2. We want grams at the bottom so that we can cancel out grams of oxygen, leaving moles of oxygen. The next step is to convert moles of oxygen to carbon dioxide. And we do this using our mole ratio, like how we did here. And we want moles of oxygen at the bottom because that's what we want to cancel, and moles of carbon dioxide at the top because that is what we want to keep. This will allow us to cancel out moles of oxygen. And to grab our numbers, we're going back to the chemical equation. We have 5 coefficient in front of oxygen, which means we have 5 moles of oxygen for every 3 moles of carbon dioxide that's produced. Now, the way this is set up, we are now at moles of carbon dioxide. We want to go to grams of carbon dioxide. That is our last step. And we've already calculated the molar mass of carbon dioxide. We're just going to plug this right back in here so that we'll cancel out moles. So moles will be at the bottom and grams will be at the top. All right, now we do our math and we get 2.84 grams of carbon dioxide produced by oxygen. Since 2.84 is less than 44.3, this means that the oxygen is our limiting reactant. If the question is asking for the limiting reactant and the reactant in excess, the limiting reactant is going to be the one that controls how much is being made or how much is being produced, just like what we saw with the recipe with the cake. The other ingredients are the ones that are in excess, meaning you're going to have some of those left over after the product is produced. In this case, the one in excess would be the propane because it produced the most carbon dioxide. So you're going to have some of the propane left over after this reaction is complete. As always, thank you for watching.